Okay, so this is going to be a number of verification tests carried out on the waveform generator. These tests are defined in Tektronix's calibration manual for the generator, and they are the verification points that I will work through before any of those measurements are made or the instruments are switched on and left running for over an hour to allow them to stabilise, and ideally you would be in a temperature stable environment as well, and then there would be more consistency in the measurements that you're making. For these first set of tests, this is going to be the frequency output measurements, which only needs to be done on one channel because the clock is common to both of the channels, and then the other two tests done in this video will be the amplitude, which will be measured on the fluke here, and the DC offset, which will also be measured on the fluke, and that will be done for both channels because the amplifier, each channel has its own amplifier that needs to be tested to be ensured it's in parameters. To do that, obviously we've got the function generator, I've got here a Keysight frequency counter, and I've got a fluke 8846A. To go along with that, I've got one of the BNC leads and a 50 ohm through terminator along with an adapter for use on the bench multimeter. So I'll just go through each of these tests and just demonstrate how they're being done, and then I'll put a table up at the end of the video to show all the values that I actually obtained and where they fall in line with the relevant tolerances. So the first test we do is to measure the frequency output, and this is done at 2 points, one on a sine wave and one on a pulse. To reset the Tektronix, I hit the default button and you can hit OK, and then that resets it back to 1 megahertz at a 1 volt peak to peak output, and that's the frequency and amplitude I need to measure the frequency. So we'll plug him into the frequency counter. The tolerance or the output given by Tektronix is to 6 decimal places, so I'm going to set this up to 9, if I do 8, so I've got this to 10 digits on the counter, and that will give me 9 decimal places, and everything else on here should be set up okay. Channel, I've got AC coupling, 1 mega ohm, 5 volts, and that will be amp pull for that. So we're at 1 megahertz sine wave, 1 volt peak to peak, and that's my frequency value. You can see it's relatively stable, and then we'll change this to a pulse, which we can either do on the keys here, is the quickest way of doing that, and then we can record that value as well. That's all the checks that are required by Tektronix for the frequency. To do the amplitude, the first thing I need to do is calculate calibration factor, and to do that I need to know what the resistance of the terminator is, so we'll put him onto there, and when that's settled we'll be able to record that value. That will go into a calibration factor that we'll use to multiply the actual reading obtained, 50.483, and then when you have that reading, plug him onto the channel output, and then we have various voltage outputs to measure. I set them to AC volts, but the frequency for these is always at 1 kilohertz, so we'll set him to 1 kilohertz. The output all needs to be sine wave, and the output is done in RMS. So the first point is 30 millivolts, and then turn the output on, and again we'll record that value, and then we can then go up to 300 millivolts, and again record that value. Next point is 800 millivolts, 799, and then we go to 1 volt. So there's your 1 volt. And 2.5. And then 3.5. This defaults to millivolts if you miss the ×1. So that's all the voltage measurement points defined. What I will do is then move on to the DC offset test. DC offset is also measured on both channels, and to get to that I need to move to a different function on the generator, which is off of the more waveforms, and then I can go down and select DC, and then I can just set an offset here, so offset at 0 millivolts, put on DC, and then if we change this now to 5 volts, read for that, you let him settle, and then we go to the opposite, which is -5 volts, and again you'd let him settle before taking a reading. And that's all those calibration tests carried out for that section.